Welcome to today's KM World webinar, brought to you by Datavid. I'm Mary D. Ojala, Editor-in-Chief, KM World Magazine. I will be the moderator for today's broadcast. Our presentation today is titled, Integrating LLMs with a Private Knowledge Platform. Now, before we get started, I want to explain how you can be a part of this broadcast. There will be a question and answer session. So if you have a question during the presentation, just type it into the question box provided and click on the submit button. We will try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response to it within a few days. Plus, all viewers will be entered to win a $100 Amazon gift card just for viewing today's webinar. And now to introduce our speakers for today. Clive Smith, Sales Director, Datavid. Tim Padilla, Director, Sales and Consulting North America, Datavid. Sylvia Churila, Co-Founder, CTO, Datavid. And now let me pass the event over to Clive Smith, Sales Director, Datavid.
Just remembered to unmute myself. Hi, this is Clive, and good morning to everyone. And thank you for spending some time with us this morning. We'll try and give you value for the investment of your time. Before I tell you about Datavid, I just wanted to spend a minute on the impact of generative AI. Now, this slide seemed like a good idea at the time when I thought about planning this presentation, but it's not actually, it's not easy to talk to it. But I think the one thing I wanted to draw out from this slide is the impact of the hype of what happened when Microsoft and OpenAI introduced ChatGPT and brought about this wave of interest in generative AI. It's probably the only time in my career, which is quite a long one, where CEOs were talking to CIOs of customers that we have relationships with, saying, you know, why haven't we got some of this generative AI stuff? Such was the volume and of hype around this. And in a way, that's been very positive because it led to a number of discussions for us with our customers, and that led to a number of proof of concepts, and then benchmarks, and then pilot projects. Now, most of the learning we're going to present today came from the benchmarks and pilot projects, because that's where we tested the technology and its integration most and more fully. But that's all I'm going to say about generative AI because we get more technical with other people later on. So I'll introduce Datavid. We have the normal 40 slide deck introduction, which I think I've got down to 6 or 7 slides, so you can all relax. But we're a company that has about 100 specialized data consultants, organized in both nearshore and offshore talent pools. We have about 20 enterprise customers, though if I'm to believe Tim, not to put any pressure on him, we should have 22 by the end of next week. And we've been growing very successfully over the last few years. And we're a consultancy that has a very firm focus on data, complex data problems, and creating what I like to call information assets from structured and unstructured data. I call them information assets simply so I don't apply the wrong term and call them a data lake when they're a data hub or a data warehouse when they're something else. But it's an information asset that allows knowledge workers to access their enterprise data. And here's how we're distributed around the world. The company was started in the UK and Romania Sylvia, who is one of our founders, will be speaking later. She's from Romania. But we, like every other software company, we have an offshore presence in India. We've started in North America about 7 or 8 months ago now, and we have currently 4 consultants there. But in a sense, we were being dragged by our customers to North America because we already have 5 or 6 customers in North America, and I'll talk about them a little bit later on. This is, I think, one of the things that differentiates us more than almost anything else. I think as customers, as people that buy services, you have a number of choices, and one is to go with very large companies or very niche, very small companies. And a very large company, and certainly the ones I've worked with over my career, you might find that there's 20% of the people, the consultants, that know exactly what they're talking about, another 30 or 40% who are capable of doing tasks within the project. And then there's a lot of fairly junior staff who are wandering around with clipboards. That shows how old I am. Nowadays, they're just sitting at their laptops, and you're never quite sure what value they're adding. Obviously, the boutique organizations are 2 or 3 gnarled veterans who've been doing something, specific for a long time. We're sort of in the middle. We have certainly got our fair share of gnarled old veterans, but the important point is that over 80% of our staff have more than 8 years experience. This really guarantees that we deliver value to customers on every project we're involved in. And that's something I'd like you to bear in mind should you want to talk to us later. Okay, so what do? We're basically data engineers, and we cover all the aspects of data engineering that are listed on the left. Increasingly over the last 2.5 years, we've been engaged in working with ontologies, knowledge graphs, metadata, all the components you need and processes you need to build a semantic data platform or cognitive search. And then in the last, as I say, year, much more emphasis on generative AI. Though I want to make the point, we've been working with NLP, which is an AI technique, and machine learning for 4 years. It's only really, as I say, when the hype and of generative AI came to the market that we started emphasizing that part of the work that we do. And this jumps around a bit because I've cut it down, as I say, from 40 odd slides. But the point here is we're completely technology agnostic. There are a lot of technologies that we don't have space on this slide to list, but hopefully we've hit the target with some of the technologies on this slide. And finally, this just illustrates a cross-section of our 20-odd customers. And as you can see, even from this slide, there are 4 US companies here. There's one, you might not have heard of Neuro Insights, but they're a really interesting company based in Texas. ASTM, the American Society, it's a standards organization. I've forgotten what the T&M stands for. ACS is the American Chemical Society, which we've worked with for more than 2 years now. And AbbVie is based out of Chicago. So we have a lot of customers, and we're getting about 25 to 30% of our revenues from North America. So we were a little bit late setting up the US operation, but we're there and we're going to invest. And it's certainly, according to our internal forecasts, North America is going to be the place where we get the most growth over the next 2 years, 3 years. And someone's just asked me, does Datavid work with SharePoint online? And the answer is yes. Everybody works with SharePoint. Let me just see if there's any other interesting questions before I hand it on. Okay, well, I think I'll have to take that one later about transformation of legacy content because it's too long to answer now. Let me just hand over now to Tim Padilla, who will talk to you a bit more about business value and how you manage this technology. Tim?
Hi, everyone. I'm Tim Padilla, Director of Consulting and Sales for North America. My role is to connect with our customers on the value of building solutions for data at scale applications. And I have a long background in delivering technology, both inside companies and through consulting partnerships. And please forgive me, I'm a little under the weather, better for it, but as my voice kind of fades here, hopefully you can hear me okay. So my portion today is about aligning business value and organizational principles with technology, which is pretty important when integrating AI into solutions. We've all been following AI's march into IT projects, and Clive mentioned this, right? And knowledge management platforms as well. But the time has come to get after building a competency. But actually, I'd wager that many of us are currently doing proofs and projects. And again, this is something we're seeing all over the place. As we adopt the technology, it's important to stay within our processes. This will help ensure you get to something that provides usable value. So generative AI and predictive machine learning are here, but still emerging technology. It's not too controversial of a statement, but how do we move this forward? I used the term avalanche on the previous slide. It's a kind of fun way to say that AI and automation cannot be escaped, but they can be prepared for. On the second point, we've all seen examples of AI getting off track or hallucinating, and we want to be sure that we maintain consistency in how our businesses and brands are represented. There's some entertaining examples out there, but they really stop being funny when it's your business. So focusing on good practices we have built and worked to instill in our organization will help ensure value, velocity, and ability. We want to enhance, not hinder, so I advocate for enabling governance. So moving into some of the terms that are important to keep in mind as we move forward through the talk today. AI solutions are often based on an AI model, and Sylvia is going to discuss in a more meaningful way later in the hour. But AI models are computational representations in artificial intelligence, and they represent our knowledge. AI models learn from AI models learn from data during a training phase, and they build a representative map of our data. Once trained, the models can make predictions or decisions on new unseen data, and this helps us surface our knowledge. Importantly, AI models powered by your knowledge management platform will maintain consistency with your business, and that's a big theme, and I say that a bunch of times through here, but it's really important as we embark on this new journey. So knowledge is essential to solving complex problems, right? That's not a controversial statement right there. But we can think of knowledge management as a journey. In this case, up the pyramid. We start by generating and managing data in compute systems, something we have been good at for many decades. But the data tends to be raw and distributed, and reports often tell a portion of the story. Now, it's like, how many times have you wondered how many employees you have in a large organization because you have 15 different HR systems? As we move to managing information, we curate our data by bringing together or harmonizing the distributed data sets and classifying the information to make it more useful. And there was a question, typical transformation of legacy content to make it a better fit for AI purposes. Great question, and I'm trying to fit that in here. I think Sylvia will give a little bit more of a technical viewpoint of it, but really your knowledge management platform is key to that. So turning our information into knowledge with modern tools allows us to embed our experience and gain insight that was previously buried in the data. And again, it's a great question to address on this slide. And the wisdom gained in our platform moves us from reactionary to anticipatory. Get ahead of myself here. in the management of our business and reduces our decision risk over time. So again, as we build a foundation for our data, we want to make sure that we're adhering to FAIR principles, and that's findable, accessible, interoperable, reusable. Keeping those principles in mind, it enhances the value of your organizational knowledge, and it ultimately makes your technology and apps more usable. It's used in the pyramid thing here. It's a firm base for a knowledge management platform. So looking at a case study, Clive mentioned that we've been doing this work with customers, and this is a good one to highlight. So this use case is about a very large scientific publisher whose users were having trouble finding relevant content. Through problem solving, it was determined that their system was outdated. Its data model did not support effective search, and their competitive advantage was being eroded. After understanding the problem, goals and a solution were defined, including enhancing their data management platform via data classification and categorization. Again, back to that excellent question of how do you take legacy knowledge and turn it into actual legacy data, rather, and turn it into actually usable knowledge. So the natural language processing using industry standard ontologies that users are familiar with, and essentially we're moving up the pyramid there. And the results are a new cognitive search platform which allows users to easily interact in natural language. And it's, again, language that they understand. It's ontologies that they're familiar with, to find and discover new content. It is expected to be a significant revenue uplift. Envisioning, building, and deploying a new application at scale on technology new to the customer in 7 months was achievable because they had a knowledge management platform to leverage, and we followed modern processes. So let's talk about those processes a little bit. Core principles are familiar. Having a business goal that is measurable. So you start something, you want to make sure that you actually define a goal. You want to be able to measure that goal so that you can understand what your results are. And in this case, you want to be able to build the new functionality. An important method used is problem framing, where we frame and reframe the problem, adopting how might we questions to enhance the competence of AI answers. So problem framing is part of design thinking and is used regularly in agile methodology. It's an iterative process for design and innovation. In this case, I'm using a simple example of a publisher that sells academic and scientific content online, is not satisfied with the performance of suggested links on their website. So let's walk through the process where framing was workshopped with the business users. First, we're going to define the problem. As people are not clicking on suggested content links from the website. You can see this from the site analytics, which are reviewed regularly. Now we can reframe the problem into something useful. This did not just jump out, but through discussion, we get to how might we enhance the quality of suggested content. And this is our new and useful statement. So understanding the problem, which is that the current search engine has limited capabilities, but we're still staying lightly technical. We need to get into the basis of it a little bit, but we're not diving down into the technology of it. We're staying functional. And we can look at a functional solution, which is based on user activity, provide accurate suggested content with article summarization. So now we have a well-defined goal and a purpose for a project that is focused on business value. And again, this is an iterative, agile process. So beyond projects in general, problem framing can also help decide if an ML solution is appropriate and begin to bridge the gap between the data and the problem. Again, just design thinking has been something that we've been doing for a while. Agile process is something that we've been doing for a while. But applied to AI projects, it becomes even more important. So applied to an AI project, having a clearly defined goal and purpose of the AI model, it's even more important with AI because you want to determine if AI is appropriate or if you can solve with a simpler method. In computer science, we talk about heuristics, which are simple methods to solve a problem. A good test is to see if you can solve that problem with your current methods or a heuristic. Having a clear understanding of the problem you're trying to solve and how the model will contribute to solving it. This will help guide downstream processes of selecting data and training models. Again, this isn't crazy talk, right? These are things to keep in mind. And again, aligning your overall strategy, your data strategy to solving AI problems. So in past methodologies, we avoided solution designing in the requirements phase. And I've been doing this for a while. So I remember the mantra of no solution designing being repeated ad nauseum, getting beat over the head with it, right? But solution designing is fun. That's why everybody goes to it. But problem framing actually allows creativity, and it keeps the conversation at a functional level to maintain velocity and agility, and we gain clear goals and purpose. So it's a way to keep agile and kind of combat that human need to actually solve problems. Okay, I mentioned data strategy. So how do we align problem solving to data strategy? And once we've defined the problem and targeted a solution, we can dive more into our data and knowledge with clear goals and purpose. Again, it starts with a clear understanding of the problem your AI models aim to solve and how they contribute to overall business objectives. This helps us understand the types of data needed, the volume required, and the quality standards necessary for effective model training and deployment. And if we ensure that AI initiatives adhere to data governance policies, we maintain consistency in how our business is represented through our technology and workflows. You get into things about data quality, privacy, integrity. Those are all really important things to keep in mind to keep your models actually performing how you want them to. And if we tie back to the example of the publisher, after framing the problem, they could take the next action steps to support the initiative. So again, we're going to work inside of a data strategy, and we're going to take actions based on a data strategy mentality. So as we move forward, again, these are slides, right? And I like to conform to the idea of three. So these are suggested highlights. But you really want to identify your data. You're going back to problem framing. You want to find data that supports solving the problem you have framed. And as enterprises, we're swimming in data, and the pyramid slide, talks about this a bit. But have we identified the right data? So again, understanding what the problem is, you can start to look at the data that you need to solve that problem. And then looking at data usage, leveraging your private data to provide specialized knowledge. And there's lots of public models that are available and helpful, but your data is aligned to your problem and your knowledge, of course. And I'm going to stop and make a note here. Sylvia is going to cover this in more detail. There's a lot behind that statement, and I do want to stay at the functional level. And then organizing our data. You want to be able to consolidate your data using harmonized data and semantic knowledge graphs will enhance your AI models. So we're going to talk about what that means in a minute. But harmonizing similar data from several systems. I mentioned many organizations have many different HR systems. I've done a lot of work with a large airplane manufacturer that literally had 2,500 different ERP systems. Right, so getting a clear picture of what your business looks like is a challenge in that model. But importantly, although AI models seem like magic, they love organized and well-described data, and we'll talk about that more in a minute. So back to the pyramid for a quick sec. So it's kind of our old friend, and we know that knowledge is essential. But how can we make that knowledge usable? So I mentioned knowledge graphs, and knowledge graphs enable AI models, but they also instill the knowledge from our data. So our knowledge can be expressed in knowledge graphs, making that knowledge usable to compute systems. The knowledge management platform can evolve to be an enabler of AI technology and bring its benefits. So remember, again, I just said this a moment ago, but AI models love organized and well-described data, and that makes training and updating models easier and more effective. And a knowledge graph is essentially a database, and it stores and expresses data differently than row and column technology. And there are many graph databases to choose from. So we're not going to really get into the benefits of them. They have their place, but a knowledge graph is definitely a different way of looking at data than traditional technology. Okay, and graph databases store data as semantic triples, and it's semantic representation of knowledge relationships. right? So they're used to represent knowledge and relationships in a way that can be understood and interpreted by computers. The relationships reflect knowledge that is stored in your data and can be used to infer relationships and infer them rather than having to explicitly state the relationship through code. And a semantic triple is a set of three entities, which are subject, predicate, and object. And I'm really trying not to go too deep into this, right? So a simple example is that I live in Moore Park, where Tim is the subject, lives in is the predicate, and Moore Park is the object. With semantics, we can express knowledge through relationships. So going a step further in that, we can state that Moore Park is a city in California and California is a state in the United States. This helps the graph and the computer implicitly understand that Tim lives in California without stating it specifically, and that Tim lives in the USA without having to code that relationship. So it's a way to actually experience some knowledge that a human might understand. Like, you might not know where Moore Park is, right? But you do know California. You know that California is a state in the United States. So it's something that actually brings knowledge to bear and experience. So in a quick summary, semantic triples are a way of expressing graph data in knowledge graphs using semantic web technologies. And so another quick look at a recent project, and defining the knowledge graph was a good segue into this use case, which is a nice example of building and using a knowledge graph to provide velocity, agility, and usability to Syngenta's knowledge management platform. So Syngenta is a large provider of scientific agricultural products, and one of the applications we help them build is Synapse, which is a next-generation enterprise search solution. Synapse uses AI technologies, including natural language processing and machine learning, to ingest, understand, organize, and query digital content from multiple structured and unstructured sources that come from both internal and external data providers. So again, that idea of processing your data, going from data management to information management to knowledge management through the technology. And so Syngenta has a rich history, but it's difficult and time consuming to find anything, which, not hard to imagine. Anybody who's worked in a large organization has seen this issue. And basically, insight was being squeezed by time spent data wrangling. Again, it's a common theme. And so turning their data into knowledge using a knowledge graph, and we process the data using machine learning, natural language processing, and standard industry ontology. So this is very similar to the previous use case that we reviewed. But the technology is a little bit different. This one's a little bit more sophisticated and down the road a bit. The outcome is scientists can now easily find data in minutes versus hours, and they can discover knowledge that they might not have seen prior. Literally, it will bring out things that, if you're working in this environment, you probably know something's there, but you just don't have a way to get to it. So bringing the data together and giving a tool that uses the knowledge of the organization to actually find that data and present it to a user is tremendously powerful. And besides cost savings and time, they're dependent processes like product development gain velocity. And of course, we're using FAIR principles to build out this application. Okay, so I'm at the point of summary, and to summarize, AI it's different, but it's also similar to other technologies. It needs to be managed and governed, right? So some of the things that we've talked about, the steps that you can take to actually govern it in a way that enables the technology. And again, we don't want to put governance up that's like building a wall and slowing things down. We want governance to be enabling. We want it to bring people together. We want it to foster conversations inside your organizations. And that's something that the newer technology can do. It makes it easier to actually have those meaningful and helpful conversations rather than pitting people against each other. And it's of particular importance in managing emergent technology, and it will help manage partners as well, which is a good example, right? I mean, we're a partner, so we like to play that up. But bringing in emergent technology, you need to bring the specialized knowledge, you need to bring velocity, and that's why you hire consulting and partners. But staying within your processes, having a governance model that's effective will help you manage the technology adoption and everybody's role on that adoption. So moving into a more technical discussion, Sylvia is going to walk us through realization of AI models.
Thank you, Tim. So once you have delimited the business case that you want to tackle by making use of the emerging AI capabilities, you need to plan your technical journey in a similar lean manner. Now considering other dimensions, such as time to market, cost of realization, toll taken on maintenance, and others. In the next part of the presentation, I will take you through the key points to consider when analyzing options, do a quick comparison between these alternatives, and finally, a demo on our take for integrating LLM models with private knowledge platforms. Getting started from a technical perspective needs to consider three things. What is the model you want to use? The market is filled with more and more options every day. Then, secondly, how do you want to use the model? And finally, what is your assessment strategy? This topic I will not expand, as the traditional A/B testing can get you the numbers you might need. So let's get started with the model. I will not make an inventory of the existing models on the market, but rather do a pro and cons comparison of what it would mean for your organization to adopt one strategy over the other. In terms of alternatives, you have two options: build your own model or enhance an existing model, or just use a commercial or not off-the-shelf model. Building your own model or enhancing an existing model requires quite a bit of preparation of data. It needs the creation of a corpus, which is a consistent set of tagged data. The tagging needs to be accurate such that the model would learn correct information according to your specialized data. Of course, if you have your content already semantically tagged or referenced in a knowledge graph, this can provide an advantage when choosing to have a private model. Selecting the route between starting from scratch or enhancing will have an impact on the amount of input data, but also on the infrastructure cost, as the model training is a resource-intensive operation. On the upside, the model will remain private and so will your data, and it will be tuned to the corresponding domain. Also, your organization is in total control on when or how to upgrade the model as the technology is advancing. But on the downside, the preparation effort is not neglectable, and it is a prerequisite before enabling any usage in the targeted application, which can extend considerably the timelines even for a proof of concept. On the other hand, you can work directly with a pre-trained model by shifting the load on the services using the model and leveraging the wealth of pre-organized knowledge in your ecosystem. Starting right away is an advantage. Opting out of sharing data with services wrapping the models is no longer an issue. However, in order to ensure that the outcomes are restricted and specialized to your domain, you need to lean heavily on interaction usage patterns such as content vectorization or prompt engineering, which make my next topic. Usage patterns. Usage pattern number 1, direct fine-tune model usage. Building up on the assumption that you have chosen to enhance your own model, the services which will facilitate your consumers to leverage the model will just be executing prompts against the prepared model. Easy peasy. However, hallucinations may occur, and as there is no way to trace how the data was represented, provenance for the outcomes cannot be retrieved. Usage pattern number 2. Data vectorization based on existing model. This is probably the most widely used and referenced way of using large language models. This way of working with models requires data transformation. All data needs to be vectorized, namely transformed into numeric tokens, based on the embedded configuration of the selected model. This way of working with models, this representation needs to end up in a vector database, which will afterwards be used in your respective services. As the vector DB will be in your ecosystem, privacy will be of no concern, as the model interactions will be instructed to use only that DB. Specialization of the outcomes will not be of any concern either. Moreover, as these vector DBs allow to specify metadata, you can even resolve the provenance issue. But you cannot neglect the fact that the vector transformation represent to some extent data duplication, and pipelines need to be set up to ensure data synchronization and completeness. In addition to this, taking advantage of model evolution requires a full rerun of the transformation of your data, which can become challenging or at least time-consuming with large volumes. And usage pattern number 3, model interrogation with generation of private context. This architecture does not add into your technical ecosystem any dependency. No new database, no new pipelines. The key of this interaction is to create sufficient context and group it with the incoming input to end up with something like, John has 3 dogs. How many dogs has John? This way of interaction can help you leverage all of the knowledge management systems that you may already have, such as the aforementioned knowledge graphs. The workings of this reside in the way that you could query your data based on an input to put together a context, which can be snippets of text, synonyms list, known terms, concepts, relations, etc. The more of a semantic structure that you have in your data, the stronger and more accurate your context will become. All of the interactions are via prompts, so your data will remain private. As your application is in control of context creation, the outcomes will be properly specialized. Better yet, as you can prompt the LLM to only use the provided context, the risk of hallucination is almost gone. And obviously, as you have prepared the context, you already have your provenance links. However, not having all of the semantic tools in place may lead to insufficient context creation, but this must not be a showstopper, but rather as an incentive to prioritize knowledge management in your organization, which will have a broader benefit over time. So, none of the 3 approaches I have presented can become a silver bullet to ensure your business case realization. All 3 of them have pitfalls on different dimensions. For example, using your own model or vectorizing your data comes with a greater cost and longer cycles for model updates, while building your context can be as strong as the existing tools in your system. The feature you have in your existing system or you want to have in the future need to play a role in the decision making. For example, if the user would do research tasks, then provenance linking would be important. If your content is accessible via entitlements, then access control policies need to be materialized as metadata for the vectorized DB or considered when building the context for the LLM prompt. Anyway, in the end, with this business opportunity that the integration of LLMs has to offer, it is the usual conundrum of prioritizing 2 out of the legendary 3, time, cost, and quality. I hope that I managed to provide some clarity with respect to the technical aspects to be considered when selecting LLMs for your organization, as we're shifting our focus towards our demo. We have a knowledge-based data platform to which we have loaded for solely demo purposes articles from the medical archive with regards to COVID-19. In addition to that, as our knowledge base, we have used the COVAC ontology and the disease ontology. Even before considering LLMs, our platform was able to support content exploration via cognitive search engine, dashboards for data analytics, knowledge graph explorations, all while federating content with semantics. With the addition of LLMs, we have managed to achieve a Q&A user experience over existing content, response provenance, while giving the user more control over the used data. You might wonder which of the options we have used out of the ones I have presented earlier. We went for the one that maximized the usage of the assets we already had embedded in our platform. Our platform supports unstructured data integration into a data hub via an enhancing data pipeline. In this pipeline, we are semantically tagging the data using taxonomies, ontologies, which lead us to enrich the knowledge graph. With this setup, we have enabled semantic search features on top of the content we have in the system. Therefore, we have selected the third option of generating context on the fly while handling user queries, namely via an orchestrating service which makes the use of all of the existing components. Once the query is submitted, the service starts to process the input. Via specific prompts, it condenses or rephrases the query such that it will be a standalone question, especially when there's a chat history. Then we are using our semantic tagging service and knowledge graph to extract the user research concepts. As not all the relevant query concepts can be contained into an ontology, we're applying an NLP task to extract the remaining noun phrases. Based on the extracted concepts and phrases, we're performing a semantic search, which would retrieve data snippets for the context generation. For additional context, we're building up the list of synonyms in the context as well. And finally, we put the query and the generated context together and submit them to the LLM model via a specialized prompt, which indicates it to just use the context that it is given. And we finally get the answer together. And now, actually demo time. And to be on the safe side of connectivity, we have done a recording of it. So here it goes. Our knowledge-based data platform. It offers configurable dashboards and cognitive search capabilities, along with search engine specific features. All this by harnessing the power of federating text and semantics via knowledge graphs and full text search. We have created a widget to prove the integration of LLMs into our platform by using solely private data. We have assessed 3 publicly available models: OpenAI, Bedrock Titan, and Llama 2. Let's start our conversation. How to measure a disease lethality. In order to get the answer, the system is fetching paragraphs from the available data in order to put together a response. As a response, we get Gompertzian analysis, which seems to be specific only to COVID-19, which is of no wonder, as most of the data is about COVID-19. Earlier on, I have posted the same question to ChatGPT, and I got 5 ways of measuring disease lethality, but none of this mentions the Gompertzian analysis, which proves easily that in order to get this response, the system has used only private data. Let's go to a different scenario. I will ask a generic question. Tell me about COVID-19. As the question, it's not very specific. Using again LLMs, this question would be rephrased to something like, what is the situation with COVID-19? Okay, so we actually get information about the situation of COVID-19. Let's continue our conversation. Which are its variants? As we account for chat history, it's being replaced with COVID-19, of course. These are some of the variants. As we all know, this is not necessarily a complete list, but we can continue our conversation nevertheless. Let's ask it a subjective question. Which is the worst variant? Okay. The system has replied with the fact that Omicron is the worst variant. But it also provides the reasoning for that. It is because the disease transmission rate is about 3 times higher than other variants. You might have noticed that we have this kind of references in here. These are actually our provenance links. So clicking on them is going to redirect us to the articles, having highlighted all of the paragraphs which have been used. So the 3 times factor, it's actually something that we encountered in here. This kind of functionalities allow the user to cross-check the information and hence ensure themselves that the system has not hallucinated. As we all know, this is a big problem when working with LLMs. Moving on to a new case. We have performed a search, a very simple one, diabetes, which has reduced the number of articles shown here to only 3,000. While you're looking at the widget, you might have noticed that we have a small remark here, source, search results. As searching and filtering are one of the core features of the platform, we have restricted the context, which is going to be used by LLM, by accounting only the search results when building the base information for the model. So now when I'm going to ask it what is TB, it will use only the information out of these 3,340 documents. Obviously, I got a simple answer, tuberculosis. I am just going to move on to the source document, and now please notice that the source has changed to current document. So any addition to the conversation is going to use only the current document. I will ask again something about COVID. What is the relation between COVID-19 and TB? I do get some information. Obviously, they don't work well together. Okay, let's say that the user is just scrolling through the document as it considers that it is something relevant for their task. And they come across an acronym which is not explained in the near context. So more questions can be asked. What is LTBI? And the cross-referencing check continues to work as we actually here get it explained. Okay, so to resume, this integration allows the user to have a chat-like experience while using only the data that is loaded into the system, while being able to make cross-references and using as source only the documents which they have previously filtered by using the regular search engine capabilities. Having gone through quite a few topics today, and then through the demo in which we have proved one reliable way of combining knowledge graphs and generative AI, the things to take away could be summarized as follows. Continue to have a lean, proof-of-value-based approach when you are implementing your AI-based business case. With the continuous evolution of AI technologies and models, running a long-term project will expose you to the risk of using something that might be considered obsolete in no more than 6 months, for example. Leverage your knowledge management system in this venture, knowledge graphs in particular. As we have demoed, and as it is more and more referenced in the specialized literature, they offer a great head start in implementing GenAI, but also more deterministic and reliable results. Not having such a system in place should not be a showstopper for your initiative, but rather another reason besides boosted data governance and enhancements for data analytics. And finally, Be critical. Do not fall under the spell of AI will solve it all. Start small and identify where AI can help you bring more for you without disregarding your existing solutions. Collaborate with your IT departments or with your data partners to evaluate your possibilities within your privacy and specialization requirements. Thank you.
Yes, so we do have some questions. Sylvia, there's one here specifically for you. When you state use tagged data, does that mean XML?
It doesn't have to mean XML. XML is a lot more expressive in terms of having more of a structured content, structured data, as opposed to JSON or JSON-LD and so on. But it's not necessarily limited to XML.
Mm-hmm. Okay.
Can I just go back to Roger's early question about describe a typical transformation of legacy content to make it better fit for AI purposes? I just want to say, I hope that the presentation has largely answered that question, but I just wanted to say, I hope one thing is clear, that feeding raw data into an LLM is technically what we would call a complete waste of time, and that you have to go through the process that anyone who's built a knowledge platform goes through to organize that data and make it data analytics ready. You have to do a little bit of extra work to make it LLM ready.
Okay. Anybody want to add to that? Okay, here's another question for maybe Clive, maybe Tim, not sure. What do you see as the main benefit of implementing generative AI to a knowledge management platform?
Well, assuming the knowledge management platform was built for a specific target user base of knowledge workers, the biggest single advantage or business benefit would be the enhancement of the search experience. We've done 3 or 4 pilots and benchmarks, and the users are able to, if they've prepared the data in the way that we're suggesting, the questions can be less precise, the answers are more accurate and effective, understands the context of what they're asking, and also they have immediate provenance of where the data has come from down to the snippet level, which is the sort of thing that most knowledge workers appreciate. That's our experience.
Yeah, and search is a it's a well-used term, but it's at the basis of so many interactions that you have, and focusing on that, making sure that the searches are using data that is properly curated, fed to the model. The model is giving you answers you actually want. I mentioned this before. There's lots of examples we see of pretty funny things out in the world, but they're not funny when they talk to you. I mean, having that ability to actually let your technology talk to your customers, it's a big step, right? You want to make sure that you do it correctly. And I'm going to agree with Clive there that search is a basis of that.
Absolutely. Are you using any open source tools to load data from the graph into the LLM?
We don't necessarily have experience in loading the data, the graph data into LLM, but rather what we are doing is actually we are querying the graph data together with the textual data, like we have demoed. Like we would normally execute a semantic search, and afterwards the output of that search we fed it to the LLM.
Okay.
If you are, now I'm also trying to rephrase a little bit the question. If you are trying to load the data that you have in a knowledge graph into an LLM, so basically you're trying to vectorize your data, you can use basically any connector to your graph database and then use the vectorization mechanisms available, depending
So,
on your vector DB, of course.
so I think what I'm hearing you say is that really, if a customer wants it to be open source, it's their choice. It's not really built into your system.
I'm referring it more like a technical solution. We the semantic search, it is built in our solution, but it's not the only solution. Of course, it's not the only way to implement it. So any open source technology which can combine full text search together with GraphDB can help you do that as well.
Perfect. Got it.
This is all that those answers are assuming you're using an in-house LLM. If you're using one of the external ones like OpenAI, ChatGPT, then you have to use the tokens. Feed it the tokens it's expecting.
Right. Okay, we have another question here. Is the provenance ranked? Interesting. Who wants to take that?
Okay, I will take that too. So provenance you're going to get if you're using either a vectorized database or you are building the context that you have demoed. When you're using a vectorized database, depending on what you consider an entry, what will be your vector, you will get the answers are going to be retrieved to you in similarity order, because that's how the vector database is being used. So you do get some provenance ranking. If when you are using the other option, all the snippets that are being used, the snippets are actually qualified on a score, like the relevance score. In a classic search engine, you have the TF-IDF score, and that is also afterwards given for the provenance linking and ranking.
Okay. While
Sylvia is trying very hard to be technology agnostic, as she should, I've got real concerns about vector databases. It adds complexity to the landscape, and you end up with upgrade paths can get technically difficult, and you have to do them a lot, because if the vector database changes, it loses all the similarities and you have to load it all again, is my understanding. Sylvia can smack my wrist later if I'm wrong.
No, that's correct. It has a few downsides, but it's not an option to disconsider. And I will tell you why. When you have a dissipated data landscape, so you don't have a central data hub, let's say you have a data mesh, if you want to be fancy, or you just have many sources of data to which you can connect. Then you can actually try to unify all of your knowledge which resides in that data by having actually a vectorized layer on top of that data. I did not went through that because it is a tremendous effort to put the data, but basically it's your first try on actually unifying all the data that may be in your systems. Plural.
Clive, you want to rebut, or are you sufficiently?
I would never try to rebut Sylvia. Thank you very much.
Okay, then. That is all the time we have for questions today, I'm sorry to say. We apologize that we were unable to get to all your questions, but as I stated earlier, all questions will be answered via email. And I would like to thank our speakers today, Clive Smith, Sales Director, Datavid. Tim Padilla, Director, Sales and Consulting North America, Datavid. Sylvia Chirilla, Co-founder and CTO, Datavid.